today. Michelle Carlson, Dr. Michelle Carlson. She leads observational and randomized controlled trial research to evaluate environmental and biologic modifiers of neurocognitive aging and dementia risk. Dr. Carlson has co-developed the Baltimore Experience Core model in 1998 and has served as a project leader on the Baltimore Experience Core trial to evaluate the impact of volunteer service on older adults' cognitive, brain, and physical health. Now, within this trial, Dr. Carlson pioneered the use of brain imaging and accelerometers to evaluate the mechanisms through which social engagement impacts older adults' brain and health and brain plasticity. Dr. Carlson continues to innovate in the integrated analysis of GPS-enabled accelerometers to determine how social engagement in daily life may impact cognitive and brain health in mid and early to late life. Her goal is to use these tools to identify the most effective ways that aging adults can buffer the brain and boost hippocampal function to delay risk for Alzheimer's disease, for which targeted treatments have yet to be identified. Now, Dr. Carlson flew in today from Baltimore, and we're so happy that you were able to join us. Thank you so much. I'm going to pass the mic over to you.
Thank you so much. I think that's a lot that you shared, and I really appreciate the opportunity to come here. And what I'm going to do is kind of unpack some of what my background suggests that I do to give you a sense for what it really means in terms of day-to-day life. And I'll look forward to any questions that you have as we conclude some of what I'm going to share with you. First of all, I think the question that I would pose to everyone is based on a growing literature and the news reports about physical activity and social engagement and cognitive brain training. These all suggest that activity is important to us in various ways. So why is activity important to us? And what I'm going to do is I'm going to start with a demonstration to show what we've learned about physical activity in particular, which is the most studied of the areas in its relationship to maintaining your cognitive health and your brain health as you get older. And what I should note is that aging doesn't start at retirement. Aging starts really in your 30s and your 40s. Therefore, what you do in your midlife will potentially have a really good impact on what you do, what you're capable of in later life. So starting early is always a great idea. And so that in terms of aging, there is no magical age when to start or stop. And you have a long window to think about how you might want to change some of the the behaviors, like increasing your physical activity in ways I'm going to talk about shortly, may have long-term benefits. So a little today may have great benefits, later in life. So let's start with an example of what we do when we test for what is a cognitive ability, and I'm going to be talking a little bit about two types. One is called processing speed. And what is processing speed, and how do we test it? Well, processing speed is a fundamental ability that we all have, and it relates to the speed with which we can perceive change in our environment. And we're always scanning our environment for change. We don't necessarily know we're doing that, but you walk into a home and you see something different in someone's home. You automatically, the speed with which you detect differences is an indication of that processing speed. So how do we test for that? Here's one example I wanted to show you, and what I would ask you to do if I was testing this for you, so you come into a clinic or into a study as a volunteer, I would ask you to look at those two pictures on the left panel, and I would ask you to compare the two, and as quickly as you could, indicate whether or not they're the same or different by clicking on the green if they're the same, green button or color box, or red if they're different. And I want you to do it as quickly and as accurately as you can. So that's a practice. Then I go over to the right side, and I might make them a little harder. So you notice on the right, they're just simple. On the right, I've made it harder for you. And so what I'm going to do is, I would give you about 18 of these, and I'd ask you to go through as quickly as you could to note whether they're same or different. And I'll use that information to determine how fast you are in processing differences in your environment. Another test that we look at and is important in terms of looking at brain cognitive health and related brain areas is called executive function. And you may have heard about executive function in the press. What is it? Well, it has to do with your everyday ability to plan and organize your day. Any given day, you may start with one set of objectives, and you might have a list, but invariably something will happen, and you'll have to adapt and update. That ability to flexibly update and adapt is a test of your executive function. So what I'm going to do here is show you some examples of how we measure it. Again, we can't really follow you in your day-to-day life and see how you adapt. What we need to do is develop tests that tap into this ability to flexibly adapt and shift your attention and do what you need to do, which sometimes involves ignoring what's easiest in favor of doing something else that's less practiced. What I'm going to do is I'm going to show you some examples of what I mean by directing your attention to what is most important, sometimes at really having to work hard to do that. So the first example is a very famous test called the Stroop test. It dates back to 1933, and here what I would ask you to do is just simply to name the color of the ink that word is presented in. And you have three choices, red, green, or blue. And I would just say press the color that corresponds to the color of the ink. Now that seems like it's an easy test, but now I'm going to move to that's an example. We'll move to the test. And in the next panel, you see that the way we do this is you're going to start in the upper left-hand corner, and I'll ask you to name aloud and go down the column, starting with the first, which is the word red printed in yellow ink. So we'll go down, and I'll do it to myself. So I'm going to say yellow, red, blue, blue, green, blue, 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 red, green. Oops, I made a mistake. What did I do? Well, it's really hard. I'm actually paying a price in naming the color of the ink because I've been trained, as most of us have been trained, to read. So we have to inhibit or basically not do something we're highly practiced and highly skilled at and instead name colors, and that's not something we're as practiced at. So I have to work hard to inhibit the response I want to give in order to give the correct response, and that's a test of executive function. Another test of executive function I'll give an example of is called the go, no, go task. And this, again, requires you to inhibit a response until it's appropriate. And this has great ecological validity. We all see stop signs, and hopefully we stop at most of those stop signs. But when we see a light, we know naturally green means go, red means stop, and yellow means prepare to stop. So here's the instruction. I'm going to ask you to say stop aloud. And I know I can't hear you, but I still want you to say it out loud. Maybe some people around you will know if you're doing this. But I want you to do it with me, and I'll do it. So what we're going to do is we're going to go through these panels, and I think we're going to move at about one every, if possible, like one every second. And basically name aloud whether or not when you're prepared to stop when the red light is preceded by a yellow light. And don't say stop unless that red light is preceded by a yellow. Ready? Begin. Stop. All right, I bet you everybody did perfectly. So that's a good test of executive function, and that gives you a better idea of how you're using that ability in everyday life to maintain independent function and to, for example, to shop, get everything on your grocery list, to be able to drive safely, and many other things that we take for granted, our executive function. Well, I've emphasized it here because it's very important to maintaining health and aging in place, aging in your home. And what we're going to show is that that physical activity is really important to executive function, to that processing speed measure I mentioned. And then more, as importantly, I think memory, we know our memories relate to how well we retain new information. So I won't test that. I think that one we probably know fairly well. So as we go forward now, I'm going to share with you some data that I hope you'll find compelling that indicates that even physical activity in day-to-day life may be beneficial to our cognitive and our brain health. So these are some findings that we published recently showing that perhaps, you don't need to necessarily exercise at high levels to see these benefits to brain health. What we did is we outfitted older adults with accelerometers, which essentially are Fitbits. And what the Fitbits allowed us to do was to look at steps per day. And what we found is that when we looked at steps per day over the course of a 1 week period in our adults, we correlated that with a portion of the brain that's really important to memory called the hippocampus. And if you wanted to get to know your hippocampus, you would take your index finger and you'd put it behind your ears and you'd push in, maybe not literally, but just metaphorically, in maybe about a half an inch, and you'd be getting closer to your hippocampi. There's one on each side, on your left and your right hemisphere. That hippocampus is a really important brain region, and it's related to memory and risk for Alzheimer's disease. So what we are showing here is that when we look at a sensitive measure of steps per day, we're finding that for just in daily activity, small increases in steps per day are associated with a larger a hippocampus. And that's important because hippocampal volume is related in other research to your risk for developing Alzheimer's disease. So this is some evidence to suggest that maybe small increases in daily physical activity, at least they're associated with better brain health. So why is that important? Well, it's important because we know there's been a lot of research over the last 10 years showing that physical activity at the level of moderate to high intensity, so exercise-related brisk walking, is good for us. It's good for our memory, our executive function in particular, and that region of the brain, the hippocampus. And when I say moderate to vigorous, I'm saying about 100 steps per minute. So think about that. That's fairly brisk walking. Well, in some cases, some people may have difficulty doing that in their own home environment. So I show you in this panel, you'll see on the left, you see a YMCA, a swimming pool, a nice facility. On the right, you see an urban neighborhood where maybe walking briskly 30 minutes a day, 3 days a week, according to the physical activity guidelines, may not be so easy to do. In addition, I myself have trouble putting the spandex on and going to the gym reliably. I'm good at it at certain times of the year, and I'm really bad at other times of the year. So I think that the challenge that we all face midlife to late life is doing what we know is good for us on a consistent, regular basis. So what do we do if we find that meeting these guidelines are hard? Well, our goal, and the research in my lab is showing among other groups, that maybe just daily walking at low intensity levels, less than 100 steps per minute, maybe that's good for you as well if you're doing it in novel and enriching environments. So that's where I'm going to go next. And in the next panel, this really is just sort of a cartoon, but it exemplifies that our challenge is we know that green food is good for us. We should eat our vegetables. We know that we should be walking or running on a regular basis. And the third thing we've been learning is that it's good to be with others. It's good to have a good social network. So one of my students put this slide together that shows that how do we do that all at once? Well, it's really hard to talk when you're running, and it's really hard to eat when you're running. But so we have all of these activities we should be doing. How do we fit this into our weekly schedule? And so from there, I'm going to move to a program where our goal is to try to achieve a sustainable way in our daily lives to increase our physical activity, our social engagement with others, and and make it cognitively challenging, so that we're being stimulated and we're continuing to use our brain in new and different ways. So the way we thought about doing that was doing it through volunteerism, under the premise that when we're social with others, it's usually around a purpose. We typically are social consistently, not necessarily to play cards or to perhaps in other ways. We may not be able to do that consistently or at high levels and sustain that. So we look to volunteering as a way to promote physical, cognitive, and social engagement that would also allow aging adults to give back a lifetime of accumulated knowledge. So that's where we go from here. At a time when retirement introduces a loss of maybe some of the contacts you've had over the course of your life through your coworkers. You may have friends and family who are like children who move away and are less available to you. And some of your friends may become more disabled, and it may be more difficult to meet them outside. And so there's this progressive constriction perhaps in some people's social networks. And our goal is to maintain that social network in ways that are meaningful. So I'll finish. I want to, in terms of time, I want to be mindful and allow time. So I'm going to talk very briefly about a program that we've developed. Actually, it's taken a village to develop this program in many years, but the program is called Experience Core. a term that was developed actually by Gardner. It was developed years ago, and the idea is that experience of aging adults is an untapped resource. That we have, that aging isn't all bad. It's not all about declines in gravity. It's actually also associated with knowledge and wisdom that can be harnessed. And so what we did is we met with school principals. Elementary schools are always in great need of intelligent resources. So we asked principals what they would need to help in their schools in terms of talent and trained volunteerism. And what we learned is they always need help with kids who need a little more time with learning how to read. They also had libraries that didn't have the support they needed. Librarians were sometimes the first to go with budget cuts. So, and we also found that some children just have behavioral issues. They need to learn positive communication, eye-to-eye messages versus you this and you that. So we learned that these were the needs of the schools. We trained a cadre of volunteers and prepared them to go into schools to work in a critical mass, 10 or more volunteers in a school, so that they could work in teams in a social network, and also that they would be a consistent presence with the children, which the principals said were really vital to these children. They need consistency, and they need to know that someone is holding them accountable for their learning. So we've created this program, and over the course of years, we've been evaluating its impact on both the volunteers, their cognitive and brain health, as well as the children. And it's designed to be a win-win-win. The win for the older volunteers, a win for the children, and a win for the school system. So today, given the time we have, I'm going to focus only on the aging adults, but there are rich data in the children showing the beneficial impact on the children's academic performance. This slide is really just to show you how we see that this Experience Core program is intended to target those three activity domains, cognitive, social, and physical, simultaneously. So that means we don't have to say, go do physical activity, come back, now we're going to do some social engagement, okay, come back, now we're going to do some brain training. It's all happening in the course of volunteering with children and helping them with reading. And these data, I'll probably very briefly mention what they show us. They've been showing us that when we compared a group of volunteers who were in the program volunteering for 6 months to a group of matched controls, which is basically older adults who were the same in every way except not volunteering. And we did use something called functional MRI, which is really kind of like a way of tracking oxygen's flow in the blood. And oxygenated blood has magnetic properties that we can image. So using this methodology, we looked to see whether we were improving executive function and the corresponding brain regions related to executive function after the volunteers were in Experience Core relative to a matched control group. And what we showed is that there indeed were benefits to executive function that were similar to those you see for physical exercise. So we were pretty excited about that. And what we went on to do from there is to look at whether or not these individuals that were in the program, the Experience Core program, were they also showing increases in their daily physical activity outside of the program. So once we empowered volunteers to go into schools, work day to day, what happened after the school hours? What were they doing? Actually, if you don't mind, yeah, I'm back. It's okay. And what we found is that being a volunteer, it's possible they could have come home and just been wiped out and spent the rest of the day and the weekend on the couch. But it turns out that what we were showing is that the volunteers relative to controls were actually showing steady maintenance of daily physical activity levels and even increased a little bit. The women showed modest increases in their daily physical activity, only the women in the Experience Core program. So what we were showing is that after the intervention, after Experience Core volunteerism, we were somehow helping to increase and sustain their daily levels of physical activity using that same step counter that I mentioned earlier. And what that told us was that maybe volunteering was not only helping them to help kids, but it was actually changing their day-to-day lifestyle activities outside of the program. Men were already very highly active. It's really the women who are at greater risk. And in general, women do tend to have greater problems with osteoarthritis, with bone density, with muscle strength, and they're at greater risk for disability. So we think that improving physical activity in aging women is very important. Thanks. And then we'll just show very quickly, I can very quickly mention, this is our ability to show how they were more active. And what we show is that the red bar represents the experienced core volunteers, again, outside of the program in day-to-day life. The blue bar is the matched control group. And what we show is that the volunteers tend to show sustained increases in their daily activity from 8 in the morning till 4 p.m., which corresponds to the same time that they were in the schools. So what we're seeing is that once they finish volunteering, they still maintain a greater level of physical activity in their day-to-day life outside of the program. Very quickly, this isn't meant to extend back to that important brain region, the hippocampus. And what we're showing here is that being in the Experienced Core program was beneficial to the hippocampus, and we showed maintenance of that brain volume, which tends to shrink with age. We stopped the shrinkage. So essentially we halted the age-related shrinkage of that region, and we actually reversed it to some degree in the men. So men in the Experienced Core program actually showed a modest increase in the hippocampus relative to the controls, the men who were controls, who are represented by that red bar. And those changes in the hippocampus are related to improvements in memory. So we see a nice correspondence between the hippocampus and what we think it does, which is to help with memory. So that's exciting for us to see. And I think with that, I'm going to, hopefully I persuaded you that volunteering in groups together with a purpose may actually have benefits that we really never realized before, that may be directly related to healthier cognitive and brain aging. What we also do in this context is we change and we reframe what it means to age. We're not talking only about all the deleterious changes, but we're thinking about how we actually have something to give back to a young generation of minds. And that here what we're doing is we're recalibrating a young child's ability to read so that as they get older, they're no longer learning to read, they're reading to learn. So our goal will be to continue to show through some other data I don't present tonight how we are hopefully affecting that child's success. And I think from there, I'd like to share with you some emerging data that our lab has been leading to think about how we take what we're learning about increases in physical activity just in daily life, and how do we translate that beyond volunteering. So we're making use of what I mentioned earlier, accelerometers, which are like Fitbits, and we're adding GPS, which essentially is already something you have in your smartphone. All smartphones have GPS, and actually they're really built-in accelerometers as well. What we're doing is we're looking at that information and trying to understand whether there are certain hotspots of activity where people just tend to be more active, and can we use that information to help design community and lifestyle opportunities that promote brain and cognitive health in ways that are just naturally occurring for some of us already. So I'm going to show you some data, and you might already know where it turns out that aging adults tend to be more physically active on a consistent basis. So this is an example of a person walking, and walking doesn't mean usually walking on a treadmill. When we're walking, most of our daily walking is occurring out in the really noisy, complex world that we live in. And we don't think much about it, but we're always navigating. And this comes back to executive functions. We're always navigating streets, cracks in the sidewalk. Maybe we have people that we don't want to run into. There are many things we're always doing. We just don't think much about it, but it turns out that requires a lot of brain ability. So let's now go and see what what we did is we asked about 25 older adults to wear basically a GPS and an accelerometer, and we tracked over a week kind of where they spend their time, where they go, and we can know based on speed, we know whether they're driving, taking a bus, or walking. And we know where their home base is, and so what we can do is we basically aggregate the data. We don't look at any one individual. We're looking at a group of individuals to see where they tend to be most active, and we use Google Maps, which is freely available, and we can identify through this figure very clearly where they tend to be most active. And here's an example of some what we call hotspots. It turns out, there may be, senior centers, for example. Churches are a very popular area to be active in our study. And on the lower right of the mall turns out to be a really hot spot for physical activity. So here's in the next panel, I'll show you how we know that. We know that because we take the Fitbit data, if you will, the accelerometer data, and we also kind of can use that. We know where they're most active, and then we use the Google Maps, and we take those 3 levels of data and we collapse them, and we get a heat map that shows us that people are not only spending a lot of time in these hot spots like the mall in the right-hand panel of the screen, they're actually also walking a lot more. So those magenta, those dark blue bars, they reflect the highest levels of walking activity. So these areas seem to be areas where people aren't sitting. They're actually spending a lot of time walking around. And that's very important information to us to think about how we design ways in which malls and perhaps churches can be sources for activity that may actually, in the next panel I'll show you, may again be related to better brain and cognitive health. So in this panel, just focus, if you will, on the right-hand side, and what you see is that we can look at total daily activity using that accelerometer, but the type of activity most strongly associated with better memory and processing speed is memory in those outdoor complex community spaces. And why is that? Well, what I'm going to propose to you is it's because being out in that complex environment, you're exercising a lot more than just your legs, and that may be the way in which we can get better brain health into our bodies and our brains, or better health into our bodies and our brains in ways that we really haven't really focused on as much as we might. And I'm going to move from there. I'm not sure how much, if we've got time. So what are some of the conclusions? One, it may be that activity in these social contexts, like a church, a mall, a shopping center, grocery store, other senior centers, for example, that perhaps that what we might be showing from our data, what we are showing is that 100 steps indoors may not be equivalent to 100 steps outdoors in these complex areas, and that it may be the complexity, it may be the social engagement. We're not sure what it is that's beneficial, but what we think that this is a future direction that's really important to explore, and it fits with other research indicating that social engagement is good for us. The other piece that I'd like to encourage is that an activity with a purpose may be really important. So social activity without purpose, there is some research done by Denise Park and others that suggest that being social by sitting and perhaps receiving health information, as some studies have been doing, isn't sufficient to give you the benefits that you need, that it may be social engagement with others in meaningful ways. It could be your children, it could be your friends, it could be through religious and or community organizations. But as I showed you earlier with the Experience Core, we showed very clearly that that purpose, one, led people to sustain that activity for long periods of time, which is not always the case with cognitive and brain training, where people get fatigued and bored with a game. And two, it led to these benefits not only in their ability, their executive function, their processing speed, it also led to benefits in their in the brain regions that support those abilities. So we think that maybe this is a target for further development. We know volunteering it appears volunteering is good for us, but maybe you don't have to just volunteer. Maybe there are other activities you can do that have purpose. And the third piece is that it's possible that what we call intergenerational engagement, that aging adults working with younger generations may be particularly beneficial. We don't know yet, but there are reasons to think that sharing of knowledge and accumulated wisdom is underappreciated, and that we really need to think more about how to value what aging adults have taken a lifetime to accumulate and give back. And I think with that, as I said, it takes a village to do this type of research, but and I've done research in other ways with ginkgo biloba and nutritional supplements, and this is much more difficult to do, but it's much more rewarding. And this is a team of many, many individuals that have really been helpful in making, allowing us to be among the first, if not the first, to show that socially, this volunteering is probably a really important target for the future, for future intervention design and for community scaling. And I think with that, we'll move to questions.
Yes, exactly. Thank you so much, Dr. Carlson. Now, this is a time where you can submit your questions in the bottom left-hand corner, and again, your questions will remain anonymous. Dr. Carlson will now take a few moments to review some of the questions. So feel free, if you haven't submitted a question yet, to submit a question. Dr. Carlson will review it, and then we will answer them in the remaining time we have. Now, while Dr. Carlson is doing that, I'm just going to tell you a little bit about our relationship with Johns Hopkins. Now, Medcan has a long-standing relationship with Johns Hopkins Medical International, the only Canadian healthcare partner selected by this renowned healthcare authority. As part of this relationship, our Medcan physicians exchange knowledge and continuing medical education with Johns Hopkins faculty like Dr. Carlson here today. If you are a client experiencing a complex medical situation and would value a broader view of treatment options, Medcan can facilitate a consultation with Johns Hopkins Medical International. Now, key benefits of our Liaison service include an experienced Medcan nurse to answer questions about Johns Hopkins expertise and treatment options, assistance in completing necessary paperwork to access care with Johns Hopkins specialists, a care coordinator at Johns Hopkins to help with scheduling, accommodations, financial issues, and more, and any arrangement of follow-up care here in Canada or consultation with a Medcan physician. So if you have any questions about this, there is information on our website, and you can contact the Johns Hopkins Liaison Coordinator at the number provided on your screen and by email. So now we are going to move to some questions. So the first one is regarding, you mentioned this right at the end, Dr. Carlson, about brain games. So you were telling us a lot about social interaction. The question is, are brain games good for me, and should I be doing my training in the morning with my coffee?
Right. Yeah, that's a very hot question right now. There's been a lot of research around and a lot of interest in popular press on brain training, if you will, or what would be cognitive training. The brain training part infers that it's improving your brain in ways that aren't really always measured by programs like Lumosity, for example, which was very popular. But unfortunately, what we're finding is that there really isn't good evidence to indicate that you get better at, what happens is you get better at whatever it is that you're training on. So let's say you're playing Candy Crush or some game, maybe it's a driving simulation game. You get better at that game, but unfortunately that training does not translate to anything beyond that game. So that's been a problem, because our hope was that if you train on a skill related to, let's say, executive function, that if you train on that skill, maybe you'll be better in your day-to-day life in driving and perhaps in other areas that are really important to aging in place. But as it turns out, the evidence suggests that our brains are really good at really just training on a particular skill. So at this point in time, it's not clear that we can really recommend that a half an hour of playing a cognitive game is better than just going out and walking.
And someone mentioned this, they said play Pokemon Go. There was a study in our McLean's magazine about Pokemon Go helping with people with concussions or other conditions to get out.
Yeah.
So how would you explain that?
I think that, I don't know the data, but I think it's certainly a plausible and a reasonable thing to expect that, again, you're out in the environment and you're problem solving while you're walking at the same time. And it seems reasonable that is actually a better model as opposed to sitting in front of your laptop or your tablet and playing a very specific game that really doesn't change very much. And another aspect of Pokemon Go is that it's unpredictable, right? You're finding these critters in the real world and you don't know where they are. Cognitive games can get really formulaic and boring very quickly, and people just don't enjoy them after a certain period of time. So I agree. There's definitely something to be said for that. I just don't know if it's been I think it's too new to know what the evidence is on how it affects aging cognition, but there's every reason to think it's probably good for you.
Okay, so we have a lot of questions, so I'm going to get through a few more. Recommendations for helping someone with reverse vascular dementia.
Oh, to help reverse it? Yeah, unfortunately right now, when it comes to dementias, once you've been diagnosed with Alzheimer's disease is the most common form of dementia. And I thought maybe it would be helpful for the larger audience to define dementia. So dementia is a syndrome that is related to cognitive deficits, typically in memory and one other domain, maybe processing speed or executive function or language. And it's also associated with problems in your day-to-day functioning, like managing your money, managing medications, driving, shopping, doing your laundry. So that's the syndrome, and then there are two most common types. One is Alzheimer's disease, which we hear a lot about, and we don't hear as much about vascular dementia, so it's a great question. What we know to date is that unfortunately, once you've been diagnosed with dementia, we really don't have treatments that can reverse that dementia, but what we can do is we can delay its progression. And because vascular dementia is often related to high blood pressure and cholesterol, one of the most important things we've been learning is that if you can control your blood pressure, high blood pressure and high cholesterol in mid to late life, meaning anytime between your 40s through your mid-60s, that treating it in those years seems to reduce your risk for getting vascular dementia and Alzheimer's disease later in life.
All right, thank you. Now, can findings of improved brain function by extension translate to lower incidence or severity of Alzheimer's? Can findings of improved brain function by extension translate to lower incidence or severity?
I see. Great question, too. So for example, in the data that I showed you, our goal is to actually answer that very question. We would like to follow up our aging adults to see whether these changes in memory, executive function, and in brain volume, if they actually do relate to reduced risk. What we have to do is we have to wait, though, to see how many of these aging adults develop dementia. And dementia is a slow, progressive process, so it takes years to see. So from a research standpoint, we're collecting those data. From the standpoint of physical exercise, there's a new large-scale randomized trial that just started, led by Kirk Erickson, Art Kramer, and among some of the most leading investigators in the area of exercise and cognitive brain health. And their goal will be to answer that question. But again, it will take a few years, probably 5 years, before the data are available to all of us to understand whether exercise in late life reduces risk for dementia through these brain pathways.
Okay, well, we'll have to follow you. And
follow them, yeah. It's a great, everybody wants to know what will happen.
All right, this next question is about diet and nutrition. So are there vitamins or supplements that can help maintain brain function? I mean, we hear a lot about omega-3, about fish oils.
Right. Yeah, and so Martha Claire Morris she's in Chicago. She's the authoritative expert in this area. But what we know from her review and then from work that I mentioned briefly with the ginkgo biloba and work with vitamins such as vitamins B, E, and C is that, and we've done work with omega-3, as you mentioned, omega-3 fatty acids, which we find in fatty fish, not in Ronald McDonald fish. That's not rich in omega-3s. That's lean fish. But when you look at fatty fish like salmon and fish like that, we find that there's something beneficial. However, when you take and extract that omega-3 fatty acid and put it in a pill, that doesn't seem to translate to the same health benefits for dementia risk. So, and that's true of a number of dietary supplements. When you extract that agent from its source, it doesn't always, it hasn't been compelling in a randomized trial. Randomized trials are sort of the definitive test of whether a particular agent works, because what you do is you randomize people. You don't let them self-select to choose that fish or that omega-3 drug or, nutritional supplement. And by randomizing, it allows you to basically make people equal in every other way except exposure to that particular drug or nutraceutical or activity. And unfortunately, there's really no evidence yet to indicate that taking, for example, omega-3 or any particular other vitamin is really boosting brain health or reducing your risk for dementia yet.
Well, in psychiatric nutrition, they came out this year with the brain food scale and just focusing on whole foods. So is that what you're saying?
I think you're right. I mean, I think that to the degree that this isn't my, I don't want to overreach, but with regard to what we know so far, I think it appears that the evidence is indicating that eating the actual foods which are rich in those sources of iron and vitamin B and C and perhaps omega-3, that those foods are beneficial, at least related to reduced risk for dementia. And so please do eat the green foods on your plate or try to find more green food. It's just not clear that you can extract that and still get the same benefits.
All right, so moving now to exercise. someone was asking, are there ideal forms of exercise for men and women? And, an ideal number of minutes. So doctors here at Medcan, they say, moderate exercise, a little bit out of breath. You're glistening with sweat for about 30 to 45 minutes.
Those are ideal. Yeah, those are the Institute of Medicine guidelines and the College of Physicians guidelines. So is 30 minutes 3 days a week of moderate to vigorous activity, which would be what you described. And that doesn't mean running, it means brisk walking. So swimming, biking. So that would be very beneficial. And it turns out that that's enough. There's some data showing by multiple groups that you don't need to overdo it, that there's a diminishing return on investment, that if you're doing this at that level, it's beneficial. It's beneficial to all organ systems, right? It's beneficial to your cardiovascular, your heart, your liver, like a lot of organ systems, including your muscles and your bones benefit from physical exercise. But it doesn't mean you need to become an Ironman, athlete. It actually, there's a point at which you don't see ongoing benefits. So it isn't that more is better. There's a point at which you don't need to do too much to get those benefits. But again, we know less about that, what I've talked about today. I think that the target being maybe we can also, among some of us, we just aren't going to be runners and we're not going to be brisk walkers. And I'm offering this idea that there is hope for those of us who don't exercise, or maybe we're not ready to exercise and we need to start with low intensity walking and then work our way up to more moderate levels.
Actually, another question about gender. Are men or women at a greater risk to cognitive loss or dementia?
Right now, using large-scale studies, like epidemiologic studies that track large cohorts of individuals, it appears that women in general are at greater risk for disability and for dementia. Women also live longer. Women on average live about 6 years longer than men, but the increased age is not the reason, that's not the source of the increased risk for dementia. We're not sure whether it's related to cultural factors, if it's related to estrogen. Women who go into menopause do tend to be at greater risk for some memory changes. We don't actually know, though, what the reason for that is, but we do know that it's probably more important for them to remain physically active to help reduce their risk.
All right. Well, thank you so much, Dr. Carlson. That does finish our seminar for today. I want to thank you for traveling all your way to Canada. We welcome you here. Now, for everyone who's joined us, a recap of this seminar will be made available on medcan.com under Medcan Insights. That will be in the coming week. And please answer our survey, which you'll receive in the next day or so. We look forward to hearing your feedback. And thank you very much for joining us tonight. Good night.
Thank you.